What's up everybody, this is Matt Brown with another IoT hacking video. Today we are going to discuss an alternative to the proprietary locked down cloud connected Wi-Fi router that you're probably running at home. And we're going to take a look at the OpenWrt One. This is a Wi-Fi router created by the developers of the OpenWrt project itself, the open source Wi-Fi router platform. And I am really excited because this is my actual home Wi-Fi router, and I'm replacing it with multiple OpenWrt One devices. And so I'm going to talk about how I'm going to be configuring these devices. We're going to open it up, look at it on the workbench, and so let's get into that. You can see here right on OpenWRT's website. Like I said, if you haven't heard of this project, you should really check it out. Links will be in the description of this video. But it's a project that was originally designed for these proprietary devices to flash onto them, to put onto them an unintended operating system that is completely open source, right? That the hardware manufacturers did not intend to be running on these systems. And they've gone ahead and they've developed this router of their own, which is really cool. And it's priced pretty competitively. It's only $90 for a router. I mean, especially these mesh routers, these days you could spend $200, $300, $400 per device, which is kind of crazy. So it's really cool that there is a free software, open source software supporting company that you can then go and support that's developing all this awesome software. And they even are going and donating some of the income to the SFC, which is also doing a bunch of great things in the FOSS community. So it's really a win-win. You get a device that was intended to run open source software, and you get to support the development of that software that runs on their hardware and other people's hardware, which is great. So let's go over to the workbench and let's start to just open up this device and take a look. So this device I actually already have configured to be on my home network for the most part. But let's go look at the desk because I've got another one here. And we're going to just walk through what I'm doing to get these things ready to go. So it comes in this nice, metallic enclosure here. We got 3 Wi-Fi antennas on the back, and then we have a 1 gig and a 2.5 gig Ethernet connection. And then right at the back, right away, I want to point this out because OpenWrt, when you're hacking on these proprietary devices, it can be really easy sometimes to put them in a bricked state where nothing but manually, desoldering or flashing a flash chip is going to unbrick the device. But they have this really cool system that has multiple flash chips, and I'm going to try to get this in focus. On the back, you can see there's a little dip switch where you can switch between NAND and NOR. So there's 2 different flash systems. So if one of those systems you put into a bricked state, you can switch to the NOR flash, and it will, you'll be able to recover it. This is, as they advertise, an unbrickable device, and that is pretty cool. So I'm going to go ahead and just open the front of this cover. There are 4 screws. I only put 2 of them on because I've been tinkering around with this device. And then you can see that the top plate comes off, which is really nice because then you can kind of have the enclosure on, and if you want to hack on this device, if you want to probe things, you can do that. So let's actually go ahead and take a closer look at this. So again, this is a router made by hackers and for hackers, and so everything is labeled nice. They're not trying to hide anything from you. They are giving you 2 different ways to get a UART console, and that's actually what we're going to use later on in this video. But let's zoom in here and take a close look at that. So you can see here, nicely labeled, we have ground, RX, and TX. Those are the 3 signals that we would usually need for using some kind of a UART to USB adapter, like you know, this one that I have over here that has USB on one end, and then it's got, you know, it's got this pin out on the other end where I really only actually need 3 of those to get a 3.3 volt UART interface to the device. But what's really cool on this device is they give you another way to get a console, and they give you a nice USB-C interface right on the front of the device, and it's even labeled console, and you can plug into that and it will show up on your computer. So let's actually go ahead and do that right now. So I'm going to zoom out a little bit. So on the back, we have the power, which is also USB-C, which is very nice. We have 2 USB-C connectors then, and then we do have a USB Type A, and this is for a pretty like special purpose for flashing firmware to it, which we will do in a little bit. So now we're going to plug my USB-C into, actually, let's wait. I'm going to show you what happens when we come over here, and I'm going to run dmessage, and I'm just going to follow dmessage here. And now I'm going to, so the router isn't even powered on yet, and I can plug in, and this console interface will show up. So it's powering just the UART console here over that front port USB-C. So we can see here it's showing up as TTY AMC 0. So all we have to do is we have to go picocom-b, so the baud rate, standard baud rate for pretty much every Linux device out there. And then we're gonna go /dev TTY ACM 0. And now we're connected to that terminal. And the really cool thing about that, if you're kind of familiar with interacting with devices over UART, usually when you like unplug something, right? Like if the part of that interface is built into the device itself, and so right now it's not being powered, right? It would be if it wasn't being powered through the USB-C side of things. So if we were connected up to those 3 pins, we wouldn't really be able to interact with this UART session unless the device is powered up. But here we can just connect. It's really convenient. We can't do anything yet because the device is not on, but let's change that. So here we go. So I'm connected in the back over USB-C, and I'm gonna turn that on, and I am going to just, yeah, so here we go. The device is booting up. That's pretty cool. There's something I wanna point out here. This is super helpful. So we do have fail-safe mode that is enabled, right? This device is made for more like hardware hackers, right? And so sometimes if I was like pen testing a device and it was a really, if their threat model was very, very strict and they wanted to get out of the device any possible way to obtain a shell of the device or to modify it in any way, I might write them up, you know, for enabling fail-safe mode, but this is OpenWrt, right? They're intending people to mess around with the device and potentially soft brick the device. Well, this is a way to kind of get yourself the device unlocked again. And so you can use this, and actually I have a video coming up of a different device that's running OpenWrt that we're going to use this to obtain a root shell on a device that we wouldn't have a root shell on otherwise. But we can see here that they do actually just drop you into a root shell. This is intentional, right? That if you have physical access to the router, that you own it, right? You get to have a root shell on it, open access. So here we go. We're logged in. We have a shell, and we're going to. So now we know we can interact with this device over UART, which is cool. But I want to make sure this is on the latest software, and this is like I want to be able to flash firmware to it, and down the road maybe I'll even experiment with like modifying the OpenWrt operating system and doing something interesting with it, right? So on their website, they have a very easy way for us to download the latest and greatest. So I'm actually going to download kind of like the bleeding edge, the snapshot here It's not exactly the stable version of the operating system. There may be some bugs, but we're gonna go for this. And then what I'm gonna do is I'm going to follow this installation path here. If we scroll down on their documentation, they have great documentation, by the way. Let's make this bigger so y'all can see it. All right, so we are going to follow this upgrade path, upgrading from the USB. So I mentioned there's a USB Type A port on the front of the device. And so what we need to do, we need to take our USB stick here, and we're going to come over to another shell here. And I've actually already downloaded the proper file that it's going to instruct us to download. So I'm going to plug in my USB. Every time, you always plug in USB Type A the wrong way. Every time. All right, so my device is now going to show up as dev, SDC, I believe. Okay, just checking and making sure that's there. Now what we're going to do is we're going to run parted. So we're going to check out the partition table here on my flash drive, and you can see I have it set up already as a FAT32, but we're going to redo this process. So I'm going to delete all my partitions on the disk, and then I'm going to say make part primary. Let's just say, I don't know, like that. So force of habit for BIOS systems is why I do that. There we go. Looks good. Let's exit. And then what we're going to do is we are going to make a file system on this USB device, because you'll see here it says prepare a FAT32 formatted USB drive. And then it wants it to contain this file, which we've already downloaded. This is also this file over here on this page, just for your information. So we are going to make a FAT32 file system on SDC1. There we go. Let's make a little directory called mount, and let's mount dev SDC1 onto mount. And now we can check that we actually have our FAT32 file system. Looks good. And now we're going to copy in our file to our USB stick. And we'll do that as root. And then we will run sync to make sure that it actually writes the file all the way to the flash drive. We will now unmount everything. If you're asking, why are you doing all this? Why doesn't your operating system just like automatically mount USB drives to your system? It's because I use Arch Linux and I don't do any like auto mounting. I do everything manually. That's just the way we do it around here. All right, so we've unmounted, so now I can safely unplug my drive here. And let's go, oh, actually, let's go back to the screen for 1 second, and let's read our instructions. Very important. Okay, so it's going to tell me to remove power. Okay, we're going to power off the device. We're going to insert the USB drive into the front, right? And then we're going to make sure that NAND boot is selected. That is already. And then we're going to press and hold the back button. It's the reset button on this device. And then we're going to power it up. And then it's going to tell us in step 7, which is not going to occur. This is a bug that I've discovered. It's going to say, wait for the LED to go green. And we're going to see why this is bugged, and it will never turn green. And I was really confused the first time this happened. But the way I was able to debug what was happening was with our UART interface. So we're going to leave this up here. And yeah, so we'll come back here and we'll observe what happens in our UART interface here. So again, we're going to power off. We're plugging in our USB drive in front, and then I'm just going to hold in the reset. And now I'm going to power on the device. And then after this is done, I will show you what the UART interface looks like, because I have to hold this down like this so that it doesn't get messed up. Sweet. Okay, so now it has completed actually, but you'll notice if you can see that it just blinks orange all the time. So always blinking orange. So here's what happened in the UART interface. It booted up. And it said, you know, starting USB, right? Because we're holding that, so it's a special boot mode. It's not going to boot into the normal operating system. It knows that it's going to look for a USB interface, and it's going to try to install the installation image that is on that USB drive. So it does all that, and then here it says, you know, okay, creating a volume, you know, bytes were written to volume. That's, you know, that's writing the data that it found on the USB drive to this thing. And then there's this error, LED loop done not defined. So there's clearly some kind of bug in their software, because from what I can understand is this is when it should be changing the LED to solid green to indicate like, hey, the upgrade is all finished. You can reboot the device now. But it never does turn green because there's some kind of, you know, undefined variable, you know, in bash or C, or there's something wrong here, and that's why that occurs. So, but this means that what I can do now is I can safely power off the device. I can take my USB drive out. And we can boot this up again, and we can, okay. So now I'm good to go. Power us on. And now it's going to boot into a fresh installation of this OS. And then what I'm going to do is I am now going to be preparing my, I've got over here, I've got a USB cord that is plugged into this desktop here. And it is a USB to Ethernet adapter. And so I'm going to plug into the LAN port, which they're not labeled. I wish they would label those better, but it's probably because you can reconfigure them to do whatever you want. But by default, the 1 gig port is the LAN port, and the 2.5 gig port is the WAN side of the router. And so you just gotta be aware of that. So, oh yes, oh yes, I need to plug in 2 sides. So I do need to plug in the WAN also to like just have internet. And this is very important because by default, when you reflash this, so I did like just plug in the device, and they install OpenWrt from the factory, and they install the web GUI. But when you flash this yourself, the web GUI does not exist, right? So what I'm going to do is I'm going to set up my interface here. So I have I've got my little, so this interface is my UART to, my USB to Ethernet interface. And so I'm just going to go here. Oh, I'm going to run DH client, but I don't want it to stomp on my DNS server. So what we're going to do is we're going to make that file right here that stores my DNS server immutable. So that way DH client won't stomp on the DNS server when I ask the router for an IP on its LAN side. Cool. So yeah, and then it gives me this error. It'd be like, hey, dude, I can't update this file, even though I sudoed the program. All right. So now, if we look, we have an IP address. Cool. So we can ping the router. So we can ping it, but if we go here to our web browser, usually you'd be able to go here and get to the web interface. But again, like I said, when you do a fresh install over USB, it does not install that GUI by default. So over here, and this is why I said it's important that I have the WAN interface all set up in my lab environment here, so that I can actually do APK APK update. So we're going to we actually have to install the GUI package. So now we're going to do APK add, and it's LUCI. That's the name of the graphical interface. And so once we install this, then we'll be able to go back to our browser and configure our router. And Firefox always wants to force HTTPS. Obviously, you can configure SSL. You can set up your own CA and everything. Oh, okay, and by default, it's going to be root, no password, and then it's going to warn you. It's going to be like, hey, you should probably set a password. We're going to set the super secure password right here. And there we go. We now have a password set on our device. And so I'm just going to show you some of the things that I'm going to do to configure this in my home network. So I am not going to use this on the edge of my network. I have a pfSense firewall that sits on the edge in between me and the internet, and I'm not changing that up at all. So I use all of my my routers, my access points in access point mode or like bridged Ethernet mode. And so OpenWrt has a wiki page here of how to set this up, but the TLDR of it is what we're going to do. We're going to do two things to configure this, and so I'm actually going to do these as two steps. And so the first thing we're going to do, we'll just talk through this, is that we're going to make the LAN interface here. We're going to come here and we're going to tell it to ignore the DHCP server, to ignore this interface. So we're effectively going to disable the DHCP server on the LAN interface. And then we're going to come here and we're going to tell it to be a DHCP client. So instead of it serving up DHCP, it's going to request on this network for an IP address from my upstream pfSense router. So that is the first thing we're going to do, but I'm going to talk through the other thing. And then the other thing is we're going to go into wireless and we're going to actually configure the wireless network. And we're going to configure roaming, which a lot of people call it mesh networking, but actually in the official IEEE standards, mesh networking means something very different than what most people mean when they want a mesh router. It's mostly a marketing term, and really what people want are one of a couple different protocols. And so I'm going to set up 802.11r. So effectively, it's like when you have multiple Wi-Fi routers, the same SSID, and you want them to just smoothly transition from one router to the other. This is the protocol that you want to set up. And there's just this one little piece of data that you have to put on both routers. And yeah, let's walk through that. So our first step is we are going to configure this. And we're going to be very careful when we do it to not put ourselves in a bricked state. So the first thing we're going to do is we're going to set up the DHCP client. We're going to hit save. Oh, no. See, that's the mistake I would make. And we're going to tell it to ignore. And then that. There we go. And then we're going to save and apply. All right. So we're just going to apply unchecked. Why not? So what I need to do now is I need to go get the DHCP'd IP address from my pfSense system, which I think I already have over here on the other screen, which I'm not going to show. So what I need to do now, though, is I need to kill this interface and not let it have like a route or anything. Where is that? Okay, ifconfig, gonna do that, and we're going to disable this interface. It's no longer gonna do anything for us. And the other thing we're gonna do, okay, we're gonna wait in our shell. So now I'm switching things up. So now the WAN port is just like not gonna get used anymore. And the LAN port is gonna plug into my upstream network. That is going to get an IP address from pfSense. And so we are going to reboot the router just so that it gets all of that fresh stuff. Oh yeah, we'll be able to, I don't need to look in pfSense. I can look in the shell because we have this UART interface, which is awesome. We can look here for what IP address we're going to get assigned. Good stuff. All right. Okay, we can hit enter. Here's our console. Can run ifconfig. Yeah, it's still configuring stuff. Still bringing up all my interfaces. Aha, here we go. So this IP address is what's being handed out, again, by my upstream router. And so now we just go into here and we can get right back into our interface, use our super secure password. I will probably change that. All right. So now we're in here, and now we're ready to set up the wireless. So the first thing I'm going to do is I'm going to take, so there are two radios. There's a 2.4 gigahertz radio and a 5 gigahertz radio on board. I'm going to just start from scratch. And so I'm going to just disable those. And so, apply your configurations. Now, on the first radio, what we're going to do is we're going to come down here. So it's already set to access point mode, which is good. That's what we want. We're going to leave this as the SSID for now. I will change that later. And we're going to select the LAN interface. This is important. I could reconfigure things to work on the WAN interface. I don't have 2.5 gigahertz. I don't have 2.4 gig Ethernet in my house, so not really important. So here we go. We're going to do that. And then this is important because then I can go into, so you'll notice, I looked for this for a long time. So you'll notice that there's 1, 2, 3, 4 tabs here. And then when we change this, another one's going to appear. So WLAN roaming, the mesh network that we're going to set up, only is available if you have, an encrypted Wi-Fi network. Fun fact. So we're going to set a, super secure Wi-Fi password here. All right, good job. And we're going to come over here, and now we're going to enable 802.11r. So this is the thing that's going to allow, I've got that router and this router, so I can have multiple of these routers, and then as I roam, a device, walks throughout the house, it will automatically transition between those two Wi-Fi routers with the same SSID. And the way that you do that is you come into here, and this is really important. You select a 4-character hexadecimal ID here. So I already have set up 1337 as the ID on this router. So when I configure this other router to have that same ID with 802.11r enabled, they will both play nicely together. And again, the wireless stations, like your laptop or your mobile phone, when you're walking throughout the house, it will smoothly transition between those two. So we're going to hit save, and we're going to do that. And then we want it, so that will set it up on the 2.4 radio, and we have to remember, we have to go back and do exactly the same thing for the 5 gigahertz radio. And you can select your channel. I'll probably do a site survey. I live in the middle of nowhere, so not a lot of interference like I did when I lived in the city. All right, so we have to make sure it's on the LAN. We're gonna go over here. We're gonna say WPA 2/3. Again, super strong passwords are important. We're gonna turn on 802.11r, and then we're gonna put that mobility domain. Perfect. There we go. And we saved it, and then we save and apply, and now it will configure our Wi-Fi to work, which is cool. And now I have completely open source, like the hardware for the most part is open source, like definitely the hardware design is open source, and the software is all free and open source software, which is pretty cool. And again, from a security and privacy perspective, the biggest thing is not even that the software is open source. It's that to use this, to configure this TP-Link Wi-Fi router, I needed to download a mobile app in order to set up my Wi-Fi router's password and the encryption type and all this really basic stuff, right? Which is dumb. You should be able to configure a Wi-Fi router without having to download a mobile app, in my opinion. And I might be a little bit old school there, but I'm really happy to be transitioning to this OpenWrt hardware and software. And it's going to allow me to start on a new project, which I won't be using these anymore. And so I will be trying to do some reverse engineering on the TP-Link Deco system to get this working with OpenWrt, which would be pretty cool. So thank you for watching this video. I hope you learned something. I hope if you are looking for a Wi-Fi router, that you would consider this platform, because I think the people behind it are doing a lot of good stuff for the open source community. They have a long track record of doing good development, and so you should give it a consideration when you're looking for your next Wi-Fi router. Thank you and have a good day.